Hello, everyone. Welcome. My name is Francis Zhu. I'm here with Shirley Buffalo and Shaka Clark. And together, we will talk about ArcGIS Insights, configuring data connections. In this session, we will cover configuring data connections to ArcGIS content, local drives, cloud drives, supported databases, and other databases. Now let's start with connecting to ArcGIS content, local drives, and cloud drives. In the Insights workbook, Add to Page dialog, you can see a list of data sources. Living Atlas contains ready-to-use global geographic information from Esri. ArcGIS Enterprise contains data from your organization, such as feature layers, boundaries, and remote layers. You can search the content by switching group here. Upload file allows you to upload data sits on your local drive. The supported files are CSV, Excel, shapefiles, and GeoJSON. You can also import files as datasets from the home page. From here, you can add one more type of files, which is File JDB. SharePoint, OneDrive are cloud drives. You can load the data from SharePoint, OneDrive to Insights workbook. The supported file formats are the same as the ones supported in Upload Files to a workbook. For SharePoint, you can add more SharePoint list. You can also navigate SharePoint subsites and SharePoint document libraries. Before you can use SharePoint OneDrive, you must register ArcGIS Insights with Microsoft Azure. Here I list the key steps and information needed for creating SharePoint OneDrive connections in Insights. I also include help document for OneDrive and SharePoint. Next, I will demo how to register Insights with Azure and create SharePoint OneDrive connections. Before start, you need to have your Insights URL ready, which will be used in registration. This is the Insights I'm going to use. Copy this portion and save it for later use. Now let's go to Azure. Under Azure Service, click on App Registrations. If you don't see it, use the search bar to find it. Click on New Registration. Give the name. Click Register. Now the Application Insights demo is created. Copy application ID for later use. Let's continue the configuration. Click Authentication, add a platform, Web. The redirect URLs is your Insights organization URL followed by MSAL callback.html. Under Implicit Grant, check Access Token and ID tokens. The web platform with redirect URIs is added. You can add more redirect URIs. For example, Insights for Online. Continue the configuration, API permission. Add permission, looking for SharePoint.
delegated permission. Under All Sites, check Read. Under My File, check Read. Click Grant Admin Consent. Click Yes. Now, your new permissions are added to your account. Now we have done everything for Insights to use SharePoint OneDrive. Before leave, check your account to find your organization name. The organization name is in your email. Here, my organization name is M40365. This will be used in Create Connection. Go to Insights, Create OneDrive Connection, give the name, paste the application ID here. Enter your organization name. Let's go to New Workbook. Check OneDrive. The new connection is listed here. You can see all my folders under my OneDrive and supported files. Click on Subfolder. Select the GeoJSON, CSV, and Shapefile. Add them. Now let's check the data. CSV file is loaded successfully. GeoJSON shape is also loaded successfully. Let's add SharePoint connection here. Create a new SharePoint connection from a workbook. Give the name. Paste the application ID here. Input my organization name. Here is your organization SharePoint site. Paste the URL here. Okay, my SharePoint connection is created. Here you can see all my library folders here, subsite, and then the SharePoint lists. Check the folder, select Shapefile, CSV, then check the data. Shapefile is loaded successfully. Now let's add SharePoint list. Select Point List, Add a list to a map card. All points are listed here.
That's all for the demo. Next, I will hand you to Shirley. She will talk about configuring database connections to supported databases.
Thank you, Francis. As Francis mentioned, my name is Shirley Bafo, and I'm a product engineer on the Insights team. And I'm going to talk about configuring database connections to supported databases. ArcGIS Insights is designed to seamlessly connect to relational databases and allow you to work with your data wherever they may be, in SQL Server, Azure, Oracle, Postgres, or SAP HANA. In version 2021.1, we have introduced support for Snowflake and Google BigQuery. We also introduced in preview support for connecting to other databases, and my colleague Shaka Clark will talk about this in detail. I have included a link to the supported databases documentation for additional information on the specific versions of databases we support. Please note that only non-spatial operations are currently supported for Snowflake and Google BigQuery. So, how do you configure database connections in Insights? There are 3 simple steps to do so. Step 1. Download the required vendor file for your database. Step 2. Add the connector type in Insights. Step 3. Create your database connection. Next, let's go through each step in detail. Step 1 is to download the vendor files for your database. Please refer to the Insights documentation for information on which vendor library files to download for your database. This is a screenshot of the Insights documentation showing the vendor files needed for Snowflake and SAP HANA. For Postgres, the file is already included in ArcGIS Server, so there's no need to download another one. I've also included links to the various vendor websites where you can download the library files. Step 2 is to add the connector type in Insights. In 2021.1 release, we have simplified this process by letting you add the connector type directly in Insights. If you are using Insights in ArcGIS Enterprise, the user account you use to sign in must have administrative privileges. Navigate to the Connector Types tab on the Settings page and click on the Add Connector Type drop-down. And choose the database for which you want to add a connector type. Next, upload the zipped library file you downloaded in Step 1. Also note that you may be required to restart your ArcGIS server for changes to take effect. The final step is to create your database connection. But before you do this, please refer to the Insights documentation and verify that the user account that you're using has the required database privileges. Let's switch over to Insights so I can demonstrate the process of configuring connections to Snowflake database. Remember, step 1 in the process is to download the vendor files that you need. So let's go ahead and do that for Snowflake. In the Snowflake user guide, in the section Downloading and Integrating the JDBC driver, you'll find a link to the Maven Central repository where you can download the driver. Scroll through the versions till you find the one that you need. The version that I want is version 3.12.16. And download the Snowflake JDBC 3.12.16 jar file. The file is downloaded into my Downloads folder. Insights requires that the files that we upload be in zipped format, so I'm going to do so now. This completes step 1. Let's switch back to Insights to continue with the next step. Remember, If you are using Insights in ArcGIS Enterprise, you need to sign in to Insights with a user account that has administrative privileges. From the Insights homepage, I navigate to Settings, Connector Types tab, and click on Add a Connector Type drop-down, then choose Snowflake. Browse to the location of your downloaded zip file and select it. Insights then validates the zipped file uploaded contains the correct vendor files and gives a green check mark when validation completes. Snowflake is successfully validated. And you see my connector type now shows up in Insights. The final step is to create a new database connection. To do this, I navigate to the Connections tab in Insights and click on a new database connection. And then select your connector type and provide the information to create a new connection. If you don't have the information to create the connection, please contact the database administrator in your organization to provide you with the connection details. Scroll down and click Add to create the connection. The Snowflake connection is added, and that completes the process. Now, you can use the connection to add data in any Insights workbook and work with it like any other dataset in Insights. In the Add to Page dialog, select Database, select the connection, and choose a dataset to add. You can check that your data comes through as expected and create some charts. This concludes the demo. To recap, I showed 3 steps to configure database connections in ArcGIS Insights. Step 1, download the required vendor files from the vendor website. Step 2, add the connector type in Insights by uploading the zipped vendor file from step 1. And step 3, create a database connection and use this connection to add data and perform analysis in your Insights workbooks. Next, I'll hand you over to my colleague Shaka Clark, and he's going to talk about configuring database connections to other databases. Thank you.
Thank you, Shirley. New in this release of Insights, we allow administrators the ability to create new connections to any relational database. In our new Connectors Guide available in GitHub, we have instructions for administrators that can use to create connections using what we call connector type bundles. A connector type bundle is an archived file containing vendor-provided JDBC driver files, properties YAML file, and properties and a dialect YAML file. The properties YAML file contains descriptions needed to create a connection to this new database. Let's take a closer look at the properties YAML file. The first section is the ID field, which is a unique identifier for this connector. The next section is the name field, of course, denoting the name of the connector type. Next, the driver section. This is the class name of the JDBC driver. Then the most important part of this properties YAML file, the URL section. Here we define the JDBC connection string required to make a connection to your database. Okay, let's go ahead down to the next section of the properties YAML file. The properties section of the properties YAML file defines the different variables in the above URL. For example, this server entry will be a property of type string with the name server name displayed, and this field is a required field to create a database connection. Therefore, without this field, we cannot create this connection. These details allow us to create an appropriate new connection dialog. The next section is the exclude schemas. This allows the administrator to list the schemas that users should not be able to see in Insights. Let's go ahead and see how to configure these properties YAML files for DB2 database. In this new version of Insights, we now support the ability to add JDBC connectors to any relational database. So to create a connector bundle, we need to create the properties YAML file, the dialect YAML file, and add the JDBC driver file. So the first part of the demo, I'll show where to find your JDBC driver, and then we'll move on to finding the connection URL for DB2 so we can configure our properties YAML file. So the best place to find JDBC drivers is the MVM repository. This URL will be part of the demo, so it will be available to you to use. Okay, so here we'll search for DB2 and find the suitable JDBC driver for DB2. We recommend using vendor proprietary. So here we'll go to the IBM data server driver for JDBC drivers. Now we'll select the version we want to download based on the database we're connecting to. It's always recommended to use the latest version. So we'll download this version and store it in the computer. Okay, so now we can search the documentation for DB2 to look for the connection string. So here we have the syntax for the connection string, and now we can use this to create our properties YAML file. So let's have a look at a properties YAML file for DB2 that I've created. Here we see, as described, we have the ID of the connector type, which is DB ID, and the name for the purpose of this demo is DB_name. The driver shows the class name, full class name of the driver. And then here we have our JDBC connector URL to DB2. So it goes in this format where we show the server name, :port, /database name, additional properties such as username and password. These properties are defined below. So we hear the server name, we're expecting a string, and this is the alias. So this is what will appear in the new connection form dialog. when creating a new connection to this data. In the demo, we saw where to download our vendor verified JDBC drivers, and we looked at configuring the properties YAML file. So the remaining part to create our connector bundle is to configure the dialect YAML file. The SQL dialect YAML file is a considerably bigger configuration file. There are 10 sections and a total of 500 lines of configuration. For that reason, we'll quickly go through these properties and then look at a demo for configuring date and time functions in DB2s. So the first part, similar to the properties file, is the ID. This is the unique identifier that we specified in the properties file. So your user should ensure that this is the same ID used in our properties file. The second section is the superclass section. This allows us to inherit from this Esri base YAML configuration. So all the default configurations will be used if this line is included. For the remainder of the YAML file, if superclass is stated, the administrator does not require to add any additional settings from this point. All additional settings will be used to overwrite defaults that have been set in the Esri base default class. The next section is the identifier strings section. Here we set variables that describe what characters are used during queries in the database. So to signify an escape character, the / icon is used in DB2. The double quotes is used to open and end quotes, and the maximum identifier length is 18. The identifier length indicates what the maximum column name or table name or index name length. The next configuration is the select top configuration. This is the mechanism Insights uses to either chunk data or paginate queries to improve performance. The first possible option, top, is only is not available in all databases and also not supported in DB2. The other expressions, limit, fetch next, and row next, are supported. So based on your administrators can now choose which mechanism to use to best perform querying in this database. The SQL clause section sets the dual setting, which allows us to do calculations without querying any specific table. This quote is as follows: select some variable from sys ibm.sysdummy1. The next setting is the offset setting. This is used in unison with the fetch next select top setting. So syntax is what the expected, it shows the expected syntax for the offset function. The final section is the SQL capabilities function. This allows us to set various variables to indicate what capability improvements can be used to improve the performance of our queries. So based on what functions are supported, we set these so that the most performant queries can be performed. The next section is the SQL function section. This lists all the functions that we have in our SQL dialect and the equivalent query syntax for this database. Let's quickly go through these SQL functions and then look at a demo for the date and time function. So the first set of functions are the aggregate function groups. In this section, we set all the aggregation functions. In the example, we see what the SQL syntax is when performing a percentile function. The next set of functions are string functions. These are all default functions except for the position function, which requires change for DB2. The next section is the date and time functions. We have three types of functions. Here we extract different date parts. We also set what date diff functions are for the different date parts, and then allow users to create timestamps from a millisecond calculation. So in our demo, we look at how we can find these functions and how to configure these functions, date and time functions. Okay. In a similar way that we did with the first demo, we can get our dialect YAML template file from the GitHub repo. This is a long configuration file, so it's easily managed in a text editor that has compare functionality. So let's open this in Notepad. So we have our dialect YAML file. Let's make a copy of this. Let's save this as the YAML file in our demo directory. So in this new file, we can navigate to the date and time functions. The first set of functions are the extract functions. Here we are trying to extract the year part of a date time field. So let's go ahead and look online to see if there's an equivalent function for DB2. So with our query, we see that the date part function in DB2 has a slightly different syntax. It expects the date underscore part for the name of the function, an actual format string, and the date time expression. The date time expression will be represented by $0, which is the variable Insights uses to mark the position of where our date time field will be entered in the syntax of the query. So from this example, we can create the date part function to remove the year from the date part field. So date part year, 0 is replaced with date underscore part, the string year, and $0. So let's go ahead and change all the other functions in a similar way. The final is our date part section. Second. So now we've updated our extract functions, we can look at the date diff functions. So similarly, let's check the internet to see if there is an equivalent date diff function for DB2. From our searches, we'll find that date diff does not exist in DB2, but the similar function is the months between or days between. So since we need to find the difference between, let's have a look at our YAML file. We need to find the difference in month, day, hour, minute, and second. All right. So this function uses months between with expression 1 being the timestamp field and expression 2 the second timestamp. So here we find the difference between two timestamps. So let's go ahead and change our SQL dialect. Right. So we can go ahead and edit all the remainder of these date field functions. Once these changes have been made, we can now open our JDBC client to check that this command will be functional in DB2. So here I use DBweaver to connect to my DB2 database and run a year extraction command. So we have years between the column birth date and hire date. So let's run that function, and we see here the ages of various employees in our employee table. So that's validated. So we've configured our dateDiff functions. So now remaining are create timestamp functions. So the first function we need is to create a timestamp function from milliseconds. So let's browse the internet for a DB2 equivalent function. So this article gives us an idea of how to convert milliseconds into a date time field. So let's validate that this query works in our database client. So this appears to be the correct function, as we have the date the 2nd of December 2014, 4 a.m. That's correct. So we can replace this function in our dialect YAML file. We replace this with our variable indicator. Right. The next part we'll look at is how to create timestamps from components. This is the most complex definition in our SQL dialect. So let's take a closer look. Using Notepad and our SQL formatter, we can look at this in a better view. So here we see the various parts of this statement. The first part is the date validation. Here we make sure that our columns are valid. So here we're checking that our first variable is less than 12 and greater than or equal to 1. So this ensures that a date field is taken, and here we actually perform the function by concatenating these variables to create a date expression similar to this. So as we want to test both a 4-day year function and a 2-day year function, we need to validate that our first variable, which is the year, has more than 2 or 4 characters. So this validation allows us to specify the 4-digit format string used in the toTimestamp command. So let's have a look for an equivalent function in DB2. Right. We do have a similar function in DB2. Oh, sorry, that's Oracle. Let's have a look. There's Oracle, and here's DB2. So we do have a similar function. Let's validate the function has the same expectation. So the toTimestamp takes a string and then followed by the format string. This is similar to the timestamp format function in DB2. So let's have a look at this. So looking at our first example, so we need to change our timestamp to function to timestamp format. So let's do that. So we changed our function. Now let's validate the format strings expected. So from our document, we know that these format strings are expected to be in caps for DB2. So with this change, we can now flatten this file and replace So let's validate this in our client tool. So let me copy this mask. Okay. So in our DB Weaver, in our database client, we can run this command to validate that a date with a 4-day can be passed with this format mask. So as we see here, we have the correct date. Let's change this to a 2-date part. Right. Therefore, our function should work as we expect. So we do support these two format tasks. So the only change I need for DB2 is to change the name of the timestamp function. So now in this manner, I can update all my remaining values. Thank you. In our demo, we saw how to configure specific date and time functions for DB2. So now let's have a look at the remaining SQL functions and the rest of the dialect YAML file. So the next section is the conditional function group. Here, logical conditional functions are defined. For DB2, all of the defaults are supported. The next section is the logical operators group. Here we show syntax for the various logical operators we support in Insights. The next section is the arithmetic functions group. Here all arithmetic functions are defined, and in DB2 we use all the default functions. No changes are required. Our cast function, here we show the syntax of how to run a cast function on DB2. This is default, so no changes are required for cast or for lag. So that's the SQL functions. So the next function is our column types functions. Here we define the names that we can use when running our cast function to convert a column to one of the specified types. So in DB2, we cannot use the decimal function when converting to a float. We need to use the float function when converting to a float. Okay. The date and time SQL tokens allows us to configure the date parts of a date and time format string. In DB2, capitalized letter codes are used. So for example, month is signified by capital M, capital M. The last section is the date format code section. This is an optional section that is used for databases that have specific date format codes used to represent a specific format string. So in this example, we see that for Microsoft SQL Server, the date format code 101 is used to signify month / day / year. Okay. So once our dialect file is complete, we can now create our connector type bundle by zipping the dialect file, the properties YAML file, and our JDBC jar file driver. With this created, we can now go to the connector types dialog and create a connector to DB2. In the next demo, we'll see how to create this connector type bundle for DB2 and how to specifically restrict functions in the SQL dialect so that users are alerted that this function is not supported. In this final demo, we'll have a look at how we create a connector type bundle using our dialect YAML we configured earlier and our properties YAML file. So we already downloaded the JDBC driver, so we have all we need to create our connector type bundle. Before creating this bundle, let's validate that these file changes are as expected. So looking at the properties file, we see our database name is db2. Our database ID is esri.db2. This is our class path name and the connection string. These are the properties we've set. We set a default port of 50,000 for DB2 and our username, database name, and password also set. At the bottom, we have our exclude schemas. So these schemas won't be visible in Insights. So let's look at the dialect changes. So as we saw in the properties change, our ID is esri.db2. The first change is the change in the escape character, and our maximum identifier is 18, as we saw in our presentation. We've changed our SQL clause for DB2, and our offset clause removes the rows setting, which is the syntax expected for DB2. Our locate function replaces the position function, and here are the date part changes we made earlier and the create timestamp changes. The final change is a column type change, changing this from decimal, which is not supported in DB2, to float. This allows us to cast columns from integers to float using this key. So once completed, we can go ahead and restrict a specific function that we don't want users to use with this connector. So new in this release, with this framework of configuration, connectors can be configured to restrict specific functions in their database. So for the purpose of this demo, we will remove the percentile function and see the behavior in Insights. So removing percentile declares that percentile will not be supported in this connector type. So with this change saved, I can now create my connector type bundle with the settings I need. So let's select the 3 files and create our zip file. Okay, we'll browse to Insights and add this new connector. Type bundle. So as the bundle is being validated, all the configurations are checked and the new connector can be created once valid. We see the new entry has arrived. And if we look at our connections type, we'll see the changes that we've made that dictate what is shown when creating a new database connection. We've added the new option of DB2 as we've specified in our SQL dialect DB name. And here we see the default settings from our properties YAML file are also respected. So let's quickly create a connection to DB2 and let's create a workbook and add data from this new connector. So let's look at the employee table that we saw. So we now see that the connection to DB2 is functional. Our date part functions behave as we expect. So the higher date, 1st of January 1995, would be Q1, January 1st, Monday, 1995. So our date parts are functional. Let's create a chart using job and salary. Here we have a bar chart showing jobs and salary calculations. So now let's test the percentile function, which is disabled for this connector. Here, the user will see a message that this statistic is not supported in this connector, and they can contact the administrator if this is something they need. Great. Over to you, Francis.
Thanks, Shaka. That's all of our presentations. In our presentation, we have shown how to add data from cloud drives, Snowflake, and any relational databases.
Here are some links you can check.
Thanks for listening. Enjoy the rest of Dev Summit. Please provide your feedback, and we are available for questions.